Okay, so to keep talking about kind of how to properly design an experiment. So we have to keep in mind those four principles. And from that four principles, we'll come up with what we'll call a completely randomized design. Okay, so in a completely randomized design, the treatments are assigned to all the experimental units completely by chance. Some experiments may include a control group that receives an inactive treatment or an existing baseline treatment. Okay, so it kind of looks like this. You have your experimental units. They might be the 50 students from that SAT course, right? Then they're randomly assigned to two groups. Okay, so they put the 50 names in the hat and they choose 25 at random. They're in group one, the remainders are in group two, right? Group one is gonna, so theoretically now among the groups, they're similar, but they're randomly assigned. So you accounted for anything else that you should have controlled, any other lurking variables. Okay, they were taken care of by the random assignment. So now theoretically, the two groups should be of similar students. So now group one can receive treatment one, and group two treatment two. There shouldn't be much difference between the two groups, so you don't have to worry about who gets what treatment. And then finally, after that, you compare their results. And that's where you're going to see, was there a difference between the online course and classroom course? Okay. So real quick example of this, and I think we'll call it quits actually after this example. So many utility companies have introduced programs to encourage energy conservation among their customers. So an electric company considers placing small digital displays in households to show current electricity use and what the cost would be if this use continued for a month. Will the displays reduce electricity use? One cheaper approach is to give customers a chart and information about monitoring their electricity use from their outside meter. Would this method work almost as well? The company decided to conduct an experiment to compare these two approaches, the display and then the chart. So, with a group of customers who received the information about energy consumption but no help in monitoring electricity use. Describe a completely randomized design involving 60 single-family residences in the same city whose owners are willing to participate in such an experiment. Then we'll talk about it. Okay, so we have these 60 houses. Okay, so we're going to want to randomly assign them so that we don't take into consideration different, bigger houses versus smaller houses, different incomes, different educations, different ages, different family numbers, members in the family. So to kind of control all of those different factors, right, you can randomly assign them, right? So you randomly assign 20 to group one, 20 to group two, and 20 to group three, okay? So we have kind of the idea that, well, do any of these actually have any effect? Do they actually help at all, right? So to even see if the display or the chart would actually be helpful or reduce electricity use, you have to have a control group, right? So the control group is doing nothing, right? They're doing everything that they would do the same. Then you're going to have group one, so that would be group three, right? So then group one is going to have the display that would see if that you could reduce electricity, okay? The small digital display. And then chart two is just going to have the chart and information about monitoring their electricity use. And again, then treatment three is going to have neither of those two to see if any of those two, either of those two would even have an effect on it. And then after that, compare the results and see if you have, if it's useful or not. And that's it for this video. Super short.